In this video tutorial, we're going to look at inversing the normal distribution. So what that means is, say we've got a probability, we want to work backwards, and we're going to find either the x value, the mean, standard deviation. So one of these things. Okay, this first problem we're going to look at, we're going to try and find the x. The others are all very similar, just using a bit of basic algebra to manipulate the formula. Okay, so the problem that we're going to work from here, I've already drawn a picture of it. Excuse the blurriness, it's blown up a bit. This example is from our ESA learning workbook. I've got it from the booklet. So the booklet's at page 37, but if you've got the larger book that's got all the standards in it, or a majority of standards in it, you'll find under the probability distributions, and the exercise is exercise J. So find the notes in the first example there. So the average annual number of hours of sunshine in Blenheim is normally distributed. So I've drawn a normal curve. It's got a mean of 2,500, so I've put that in. And a standard deviation equals to 120. We want to find the average annual number of hours, so I want to find the x of sunshine that is exceeded by 60% of the time. So we have to read that piece carefully, exceeded by 60% of the time. So if I had it up here and had 60% down here, is that number exceeded by 60? No, that number would be exceeded by 40. So it goes down here. If I put it here, this number of sunshine hours is exceeded by 60%. Exceeded 60% of the time. Okay, so it's this value of x that the problem's asking us to find. How many hours? Okay, so 60%. So we know we've got 50% on one half of the curve. That leaves 10% for this piece here. Now, because we are probabilities, that's 0.1. Remembering that our table here gives us between the mean and that z-score. Mean and the z-score. So that 0.1, and here are our probabilities in here. They're all 4 decimal places. So I'm going to turn this into 4 decimal places. And we're going to try to find a z-score that matches that probability. Because we'll have a quick look at the formula. If we can find the z-score, we know the mean is 2,500. We know the standard deviation was 120. So if we can find the z-score, we've got the one variable unknown that we want to find. Okay, so let's try and find the z-score. Now, one thing that we have to be a little bit careful about is the z-score to the left of the mean is going to be a negative z-score. So I don't forget, I'm going to go z equals negative. Right, so I'm trying to find a probability, a z-score that would give me a probability of 0.1. So I look at the table and I be very careful because these are z-scores. Down here, and these are probabilities. Get rid of those marks so I can read it. Okay, so I'm looking for a probability of 0.100. Now I'm getting pretty close here. This one, it's overshot the mark. It's too big. So we're going to look at this one here. Now, to make that perfect at 0.1, we'd need to add 13 onto the end. So let's see if we can add 13 onto the end. We can add 12 or 15. 12 would be the closest. So I get rid of that one that was overshot. So the z-score that matches that probability is 0.25. So the z-score is 0.25. 0.25, and I want to add on 13, but I can add on 12. It's closest. 3 goes on the end. So that is my z-score that gives me a probability of 0.1. Okay, so let's fill in all the knowns. Negative z-score because it's on the left. Negative 0.25 1.53 is equal to, we don't know x yet, minus the mean, all divided by the standard deviation, which was 120. Okay, so to get rid of all these other things around the x, we've got to get rid of the 120. Now, when we get rid of the divide by 120, we have to, we're going to times by 120. Okay, and the next thing we're going to do is get rid of that minus 2,500. So we're going to add 2,500, and then we'll be left with x on this side of the equation. Okay, so we're going to multiply all that around, and we're going to be left with, looking at the answer, so I have to do a calculation, 2,469 hours, 0.64. So about 2,470 hours. Okay, so we're just manipulating, and the answer to the question was find the average annual number of hours of sunshine that has exceeded 60% of the time. Well, the number of hours that's exceeded 60% of the time was 2,470 hours. Okay, so if you're looking for mean or standard deviation, you just do the same little bit of algebra, undoing what has been done, so you're left with the one unknown on one side of the equals. Okay, so that's the end of inverse normal.